Hi class, this is Mr. Morris, and we are talking today about valence electrons and ionic compounds. So a lot of this is going to be review for you, but I want to make sure you've got a good handle on this as we move forward towards our next test. This is the last topic before we review and take the Unit 1 test. Whether two elements will form a chemical compound or not, whether they'll form a chemical bond or not, is determined by the interactions between the blank electrons, well that's valence electrons, between the valence electrons and the nuclei of elements. Okay, I think that's something that we kind of know. The interaction between the valence electrons and the nuclei of the elements involved, that tells us whether or not two elements will form a chemical bond. It also determines what type of chemical bond we're going to get. Elements of the same group on the periodic table, remember a group is a column, they tend to form similar compounds. Typical charges of ions and ionic compounds are determined by the number of valence electrons and by their location on the periodic table, basically the same concept. So we've got these tables here, and the way that it looks might seem a little bit strange at first, but the whole purpose was to line up a couple columns here. Alright, I wanted you to see that those are the same column on the periodic table, because in those two columns it is potentially possible that you could have a different charge, and it depends on whether you have a metal or a non-metal. And remember, these are typical charges. There are occasionally deviations from this, but they're the typical charges. Group 1 or 1A always has a charge of positive 1. Group 2 or 2A is always positive 2. Group 13 or 3A is usually positive 3. And remember, this is if they are metals. Okay. And group 1 and 2 are always metals except for hydrogen. Group 14 or 4A is positive 4 if it's a metal, typically. And group 15 or 5A is typically positive 5 if it is a metal. Just remember, these last three, this is typically the case. Not always true. Okay. Then we go over to the nonmetals. And these two, it's typically negative 4 if it's a nonmetal. It's always going to be negative 4 if it's a negative ion. And if it is in group 5A, that'd be negative. I'm sorry. No, that's right. Negative 4. This will be negative 3. 6 is negative 2. 7 is negative 1. And then 8A has no charge. Now, remember, the reasoning for this is because they want to be like noble gases. So these elements, they all kind of want to be like noble gases. So they tend to lose or gain electrons in order to find, to reach that noble gas configuration. So a metal will tend to lose however many valence electrons it has, and when you lose electrons, you become more positive. Nonmetals, they've already got a lot of electrons, so it's easier for them to just gain another electron or 2 or 3 in order to get a full valence shell. So however many electrons they have to gain to get to 8 valence electrons, that's going to tell you what the negative charge is. Alright, let's look at some examples down here. The compound CCl4 is non-flammable and was once commonly used in fire extinguishers. On the basis of the periodic properties, which of the following compounds can most likely be used as a fire-resistant chemical? Which one could be used for the same purpose? Okay, and we see this where it just says it's most likely. Really what we're saying by all of this is it should have similar properties. And that goes back to the idea that if they're in the same group, they have similar properties. So I see that carbon, carbon's in group 4A, and chlorine is in group 7A. So we want to find a compound that has something from 4A and another thing that's from 7A, and we should have 4 of those 7A elements. So 7A is our halogens. I've got chlorine with 3, hydrogen with 4. Okay, well, hydrogen is not a halogen. Bromine, it's a halogen. There's 4 there. And then chlorine has 2 right there. Okay, probably not that. This is the one, because bromine is a halogen, and I've got 4 of those in the compound. So it's got the same basic form, 1 carbon and 4 halogens. Same formula basically, it's just a different halogen. It's likely to have very similar properties. Look at the next one. Chlorine atoms can decompose O3. Okay, it says chlorine atoms, so we're not talking about Cl2, it's just single atoms. Through certain steps of a reaction mechanism. Species other than chlorine can also decompose O3 through the same mechanism. Which of the following chemical species is most likely to decompose O3 in the upper atmosphere through the above mechanism? So which one's most likely? Once again, we're looking for something with similar properties. So probably another atom from the same group as chlorine. Well, helium is not. That's a noble gas. Bromine is from the same group. Nitrogen, well, for one thing, it's N2. That's not likely going to be the case. But also nitrogen is in a different group, and oxygen is also in a different group, and we've got subscript of 2. Yes, B looks to be the right answer, because this is a monatomic halogen, just like chlorine is. Basically, it's the same thing from the same group, and that's what we're looking at with those types of questions. Atoms of an element, Q, have the electron configuration of the valence electron of the valence level shown above. So NS2, NP3, where N could be any number. It could be 2S2, 2P3, 3S2, 3P3, 4S2, 4P3. Could be any number other than 1 because it's got the P sublevel in it. So what group is this? How many valence electrons does it have? Well, I've got 2 in the S sublevel, and I've got 3 in the P sublevel. So you add those together, you're going to get 5 valence electrons. If I have 5 valence electrons, that means I'm in group 5. And group 5, as a nonmetal, has a -3 charge. And since I'm bonding it with calcium, is what it says here. It says write the formula of the compound most likely to form with calcium, Ca. Well, that's a metal. Metals and metals don't really form any sort of covalent or ionic bond. So this is probably going to be an ionic compound where calcium has a +2. And because this has 5 valence electrons, that means it's in group 5, which means it's going to have a -3 charge. So Q has a -3 charge. So if I were to write my formula, I need to find the least common multiple of those, which would be 6. And then I could divide. I could say, okay, I'm going to have Ca3, because 3 times 2 gives me a +6 charge. Q2, because 2 times a -3 charge would give me a -6 charge, so it would be canceled out. Ca3Q2 is the answer for this. 5 valence electrons tells us it's in group 5A, which in turn tells us its charge is -3, and that's why we can deduce what we did over there. And then we have one last question. Chlorine reacts with the element magnesium to form an ionic compound. Based on periodic properties, identify a molecule, X2, so our unknown molecule, that is likely to react with magnesium in a way similar to how Cl2 reacts with magnesium. So it's got to be similar in properties. The best thing is going to be look in that same column. So if you were to look at the periodic table of where chlorine is, the same group, you're going to find fluorine, bromine, and iodine. And we want them to be the diatomic form, just like Cl2. We're going to have F2, and you could pick any of these. You could pick F2, Cl2, or that, no, Cl is already the one we have. So F2Br2 or I2. And the explanation, because they are in the same group on the periodic table. You could also say they have the same number of valence electrons. That's an alternate way of saying it. And as a result, they would have similar properties. All right, that's it for these notes. You've got a little bit of practice to do with this. If you've still got some periodic trends practice, you can work on that. Make sure that you're staying up with your notes, your binder. I'm going to go ahead and post the review for you to start working on, and next class will be a review in getting ready for the test, and you might have a quiz in that class. I'll make sure that I let you know if that's the case or not. Best of luck and have a good day.